All right. Here we are. Oh, okay. All right. Okay. I probably need to toggle one of these. So if I
just saw you guys go mute. I cannot hear you. Just want to make sure that you guys are able to see my screen. So I just shared my window for the PowerPoint.
so if
Okay.
I don't know why all of a sudden we're having this echo. One moment.
Okay.
What changed? Is this when he started the share screen? No, this is when he unmuted here. Sorry, say that again? Yeah, he just unmuted here, and so when he unmutes, suddenly the feedback comes in. When we unmute?
Yeah.
When you unmute here? When he unmutes here. Are you still muted? Or
No, I'm not muted, but I hear myself, and that's good. Yeah. Can you hear me?
Yes, I can hear you.
Okay. You're quite faint still.
Oh, okay. I maxed out my sound
I think it's the sound
volume.
from that thing because it's delayed.
yeah, no, we hear it's there's a fork. So this is going in the speaker, and this is going in the computer, and the computer is going back in speaker.
Yeah.
So yeah, I'm on it.
Right. So in the meantime, we'll.
Is the gentleman his headphones are working properly? So they could have disconnect when he restarted the computer. Could we ask? Sandeep, is your headphone working?
Yes, yes, I can hear you, and
I mean, we don't need to say anything, right?
Okay.
So far, so you can. But I'm not sure why you cannot share your screen.
yeah, I selected the window and then I clicked share.
One is OSIG and one is OSIG.
Yeah.
Sorry, could we? I know we have other issues, but could we double check with him that sound is not coming out of his speaker?
Yeah.
Okay.
You heard that, right?
Yeah.
Yeah.
Let me just make sure. Yeah, the sound is not coming from my speakers.
So why is this? Can I mute? Not sure what's going on. Are we still echoing? Yeah.
A little bit.
Right.
So I'm going to reshare my window again to see if you guys are able to see my PowerPoint. I just did. So can you guys see my PowerPoint slide?
Not yet.
No.
Okay. I'm going to share my entire screen just to. Okay.
Don't use Crowdcast again.
Okay. Yeah, I've just clicked share my entire screen. So are you able to see anything?
No.
Okay, so maybe we have to throw in the slides from your side.
Yeah, I can try that. So, what happens for you if I do this?
Okay, I can definitely see the slide,
Yeah.
but I'm only seeing half of it. If you can make it fit the full screen or something, that'll be great. There you go. Okay.
So this works, right? So you
Yeah.
can make this full. It's just that we need to change the slides for you.
Right, right. The only thing is, I was going to show some live demos on the software on my computer, but that's okay. I think we'll have to try it at the end of the presentation and see if I can.
Yeah.
But I can at least finish the presentation with you doing this. Okay, so
Yep.
let me know. We can get started.
Can I check something? You know that the app. Do you mind if I ask?
No, go ahead.
I think maybe that loop thing is from the software, but I'm not sure.
So the only thing that I think we changed is the setting from the Blackmagic to Scarlet. You make that a focus group. Do you hear script?
I'm sorry, I don't want to break anything.
So where did we do that? Did this right? We
But it was default, so I keep the same Scarlet, but not in. Now, if we take this, we won't have sound because this is going nowhere.
I see. Right.
Yes. So I'm sure we need to keep Scarlet. Now that loop, I think it's made for you to hear yourself when you speak. I'm gonna mute and
Yeah.
unmute.
Now we can mute ourselves.
Okay. So let me know when you guys want me to get started, and I can get started and give you cues for moving on to the next slide.
You can go ahead.
Yeah. Okay. Sweet. All right. We'll get started. Sweet. Cool. Thank you all for joining the presentation. So finally, we're here. So today I'm going to introduce COINSTAC, the software tool which will help us do federated analysis on neuroimaging data. And this is the overview of what I'm going to present on. I'm going to present on the use case for COINSTAC and describe some features of COINSTAC, introduce the interface, and also finally COINSTAC Vaults, which is going to be the major part of the presentation today. And I'll definitely have some time for feedback. So if you want to jot down your questions or throw it in the chat, that'll be great. Okay, we can move on to the next slide. Okay, so this is the background use case for COINSTAC. So with increasing big data collaboration around the globe in neuroimaging, and with increased data processing capabilities, we have more opportunities to do big collaborative projects across the globe. And the only one of the big things that is blocking us to do big collaborative brain research projects is obstacles to data sharing. And there are many reasons for that. Obviously, some of them I have noted down here, which are basically permissions to share the data, HIPAA rules, privacy issues, misuse of data, and preserving the privacy of the participants, and lacking permissions of the institutions. So big collaborative projects still happen, but it does take a lot to cross these barriers and make these big data projects happen. So this is where COINSTAC comes in. You can move to the next slide. So COINSTAC stands for Collaborative Informatics and Neuroimaging Suite Toolkit for Anonymous Computation. And at the core, it enables federated analysis of neuroimaging data and other kinds of data as well without sharing the raw data. Only the derivatives of the data are shared between the sites and the central node. And that's how the computations and the group analysis are run. And this kind of federated analysis can also help in reproducibility of the results when you have standardized data processing, and it will help with big data collaborations around the world. And what we can do is do a lot of group analysis with advanced machine learning techniques, and also available are differentially private computations. Yeah, you can go ahead. So here's an example of doing federated analysis in COINSTAC framework versus pooled data analysis. And what we are trying to show here is that if we do the group analysis in a decentralized way versus pooled centralized way, that the results are still interpretable and meaningful. So in this specific example, we are comparing a distributed joint ICA on fMRI data versus pooled ICA, running pooled ICA. And we're using a metric called Amari index, which compares the distance between the invertible matrices. It's a metric to compare ICA algorithms. And so we noticed that the results are comparable to pooled analysis. And on the right side is a decentralized TS application of T-stochastic neighborhood embedded algorithm on MNIST digits dataset. And what we notice is that even splitting the MNIST digits dataset into different sites and performing a unsupervised dimensionality reduction algorithm like TSNE on the data still gives interpretable results, and the digits are still well separated. So the idea is that COINSTAC can be used to derive meaningful results while making sure that the raw data is not shared between the sites. Yeah, we can move on. Here's another project that was done using COINSTAC framework. And this was fMRI data from 14 sites in India, UK, and China, about 2,400 participants. And this was a substance use project with alcohol and tobacco. And the idea in this is that such an analysis outside of COINSTAC framework typically would require tons of collaboration between the PIs, whether it's standardizing the group analysis and sharing the scripts and performing analysis. And so this was done within COINSTAC framework. And we noticed that there is hyperconnectivity. There's FNC connectogram plots here that are shown. It shows that there's much more hyperconnectivity in participants using alcohol versus tobacco. So this is just a use case to show that huge projects like these can be possible within COINSTAC. Keep going. And here's the framework for COINSTAC. And it's an Electron standalone application that can be installed on Windows, Mac, and Linux. And computations are run inside Docker and Singularity containers on the user's local machine. And as we said, the local data never leaves the host, and only the derivatives or the results from the algorithm are shared between the nodes. This is a little bit, gives you a little bit about the frameworks that we use in the backend, GraphQL, Node.js, etc., and Mongo database. So yeah, you can keep going. Okay, so here's the UI for COINSTAC. And the first step is that a owner of a consortia can create a login in COINSTAC, and he can make the consortia public or private depending on the visibility of the consortia to other COINSTAC users. So he creates the consortia, he invites other users to the consortia, and then he creates a pipeline depending on the type of data set that he has. In this case, it's running regression or free surfer volumetric measurements. So he defines the options in the pipeline, as you see in the middle picture. And once he's done with that, then the other users map their local data on their machines. And when all the users map their data, the algorithm is run. And on the right side, you see the results. And some other features in the COINSTAC include guided point-and-click UI tutorials and connecting data that lies on network volumes. And it has support for running Docker and Singularity. So yeah, we can keep going. Here are some of the current algorithms available in COINSTAC, and you can see that there's various algorithms ranging from regression and different type of that run on different type of data sets. Currently, we support volumetric measurements from free surfer process data and gray matter volumes that from structural MRI data that are processed through the VBM pipeline in SPM. And for fMRI data, we have decentralized dynamic functional connectivity, independent component analysis, and also Mancova and other type of secondary analysis after running group ICA. And we have some other machine learning algorithms here. And most recently, we have also started supporting half-pipe pre-processing algorithm in COINSTAC. Yeah, so we can keep going. And here's a way to contribute to our algorithms. We choose a programming language for creating our algorithm, for example, Python, and you download the COINSTAC. There's a COINSTAC simulator tool, and you test your code with the COINSTAC simulator, and you package your code inside a Docker container, which makes it standalone. So you can have any programming language of your choice, so long as you interface it with inside the Docker and follow the COINSTAC formatting standards, then we can integrate that into the UI of COINSTAC. Yeah, keep going. So this is the COINSTAC UI, and in the computations tab, you just notice all the different computations currently supported by COINSTAC. And we have created links to the GitHub repos and some sample data that users can download and test that specific computation and see the results. And that gives the users an idea of how the data should be formatted and what results they should expect. You can keep going. Yeah, you can go to the next one. Okay, perfect. So this is an example of running a structural MRI VBM pre-processing pipeline using COINSTAC. You can play the video. This should be a, are you able to play the video? Okay, there you go. You create the consortia, you give the name. And you go to the pipelines tab and you create a pipeline with a name and you add the pipeline computation. In this case, it's VBM pre-processing. And if you have covariates for this data, which you may want to use for running regression, for example, down the line, you can give it the covariates. And if you have the data type, nifty files, you can give the data type. And these are all the options available in the VBM pre-processing. And these are traditional options that are available in the SPM toolbox in MATLAB that we have exposed here on COINSTAC. And you can change all those options based on the pipeline. And you save the pipeline and you map the local data. And in this covariate CSV file, you have your covariates along with the paths to the actual raw SMRI Nifty, T1 weighted Nifty files. Now you start the pipeline. And this one is running completely on the end user's local machine inside a Docker container. And here you see the results of the pre-processing. And you can now use these warped gray matter images to run other algorithms down the line. Group analysis, so to say. And here is a subject that has been pre-processed. You can see all the outputs from the pre-processing. Okay, so this is the normalized gray matter volume from a subject. So when you are setting up a group analysis, COINSTAC definitely helps in having a standardized pipeline across the board so that you're able to run a group analysis in a standardized way. Okay, we can move on to the next slide. Okay, and here we are introducing the feature COINSTAC Vaults. And Vaults basically helps in, Vaults are curated data sets that are made available as a vault in COINSTAC framework. And vaults come in handy because when you want to set up a consortia and run a group analysis, you need the user's local data and the computer always turned on so that computations can run in a consortia. Vaults are pre-mapped and curated data sets that are made available to COINSTAC users at all times because they sit on a server and they're made available at all times. So any organization with their data, they can make it as a vault in COINSTAC, and we have developed a process for doing that. So yeah, so this is the vault creation process. We have a vault client that the user can download, and say he has some data that he wants to share in a COINSTAC framework as a vault. He downloads the COINSTAC Vault client, and he installs a Vault client and connects the data set to the Vault client. The location of the data set and the description of the data set, etc. And he works with the COINSTAC team to get the API keys and stuff to set up the connection between the data and COINSTAC. And once it's ready, it is made available as a COINSTAC vault to the end users in COINSTAC. And now users can actually use the vault data as one of the data sets along with their local data. So, and this can be very helpful for doing group analysis on public data sets when they have less access to data. So vaults come in handy for that. Okay, we can go to the next slide. And this is a video of running a regression on gray matter volumes using vault data and a user's local data. So in this case, the dependent variable is gray matter volume from all the voxels in the T1 weighted image. And here in the pipeline creation process is where user selects this vault data. In this case, it's trends BBM vault, and he adds the computation step. In this case, it's regression BBM, and the vault comes in with all these covariates that are made available to the users, and users can select whichever covariates they want to use. And save the pipeline. They make sure that the pipeline is active. And here they're also adding themselves as another user on the consortia. And now they map the local data that they have. And you want to make sure that you have the same covariates available for both the vault data and the local data. Now he runs the pipeline. So in this case of regression, yeah, there should be some results here. Yeah, we notice all the beta weights corresponding to all the independent variables here. And you see local stats and the global stats. And those are the beta, mean betas that combined vol data and the local data. Those are the global stats. So here's an example of combining local data with these vol data sets, and you can increase the statistical power of your analysis or check how the results hold up when you combine it with a public data set. So this is where vols come in handy. Can move on to the next slide. Okay, so here's are all the current vols that are available in COINSTAC framework. And we have curated these data sets and made sure that they are compatible with certain computations that are, so users, this is the quickest way to test COINSTAC framework and run computations on vols. So users do not even need to have Docker or Singularity container on their local machine, because all the processing happens on the server and the vols are set up that way. So users can right now log into COINSTAC and select any of these vols, and if they have a local data that is similarly pre-processed, they can combine that with the vol data and run computations on it. Okay. And more information is available and on the COINSTAC website for the vols. And here's some research possibilities for COINSTAC framework. And really my goal of the presentation was to introduce COINSTAC and see if you have any interesting use cases for COINSTAC, and just try it out. And if you have any public data sets that you want to make available as a vol, we can work with you on that. And if you want to contribute to new computations, as I said, we can work using the current process. So you can contribute to the code base and the computations. And if there's any interesting grants that we want to pursue using COINSTAC framework, that'll be great. And here's the link to the COINSTAC GitHub repo. So all these are different possibilities. So I just wanted to share that. Okay. And here's the upcoming workshop. And we have 2 workshops coming up on August 1st and 15th. August 1st is already maxed out in terms of capacity, but August 15th is still open, and it starts at 1:30 p.m. EST. And if you can email Emma Davis at this following email to enroll in the workshop, we will go through live demos of these vols and a more in-depth description of the computations and interpretation of the results and such. Okay. Okay, great. So this is our team, Dr. Vince Calhoun, Sergey, Brad, and Jeremy, and myself. And most of them are in person at the OHBM conference. So feel free to say hi if you see them, and ask them any questions related to COINSTAC. And in fact, Brad is here in this room, so we can any questions relating to computations related or computation author related questions can be targeted to him, so he's available for that. So yeah, thank you all for the time, and I can take some Q&A at this time for feedback and questions, and anything about the UI or questions related to how can we make this more useful for collaborative projects and such. And as I mentioned before, that this is fundamentally using neuroimaging data, but it can be expanded to other types of data sets, whether it's EEG, MEG, or even other kinds of data sets. So we are always looking for new use cases to implement in COINSTAC framework. Yeah. So yeah, thank you all. So I'll just leave it open now for any questions and feedback and such. Maybe if you guys can turn on your audio, I can
Prepare yourself for. Okay, yeah, I was just saying, thank you very much, Sandeep. It was a very clear talk, a very nice demonstration of how you can use COINSTAC for VBM analysis in particular. Can I just open the to questions from people here? Yes.
Thank you very much for the presentation and also for the work. One question I will have, this type of pipelining efforts, I think the biggest challenge is very often there are some variations in a pipeline more than parameter settings that requires specific work and adaptation. And
Right.
I believe this is a big challenge. And I agree that it's difficult to handle this. But in COINSTAC, for example, is there a mechanism to manage this type of pipeline variations? Is the way to deal with this is to create a pipeline, or did you think about this challenge, or do you have any comments on this?
Sure. Yeah, thank you for your question. So yeah, we definitely understand that there's so many ways to set up a pipeline, and especially for pre-processing the data and running a group analysis. So we have included one that we have most commonly used in the past in terms of pre-processing pipeline. But in the future, our idea is to work with other PIs who are doing pre-processing and other analysis in their own way, and work with them on integrating their computation into the COINSTAC framework. And as I mentioned before, the process is pretty streamlined. You can write your computations using a language of your choice and package them inside Docker, test with COINSTAC Simulator, and then our UI developer will integrate the computation into the COINSTAC framework. And then you have a consortia which can use that pipeline to run a project. So this is a tested process that we have done with other PIs in the past. So going forward, we would love to do the same. Yeah.
Thank you.
Yes.
So since your last or to repeat the voice, I think your very last was about like the fact that you could expand COINSTAC to use different data sets beyond just the regular imaging ones. But is there a specific requirement as to how the data needs to be normalized to be available through Vaults? Because is it for instance like bit specific or bit slice specific, or like how can the data be formalized in any way? How would that be exposed to the rest of the COINSTAC chain?
Sorry, I lost the last part of your question.
I think the question, like, does the data need to be in bits format in order to be kind of easily readable by the COINSTAC processing pipelines?
Okay. Is the question if the data needs to be in bits format in order to be readable?
or any other like specific file format?
Right. Yeah. So as of now, it's a COINSTAC proprietary format, so to say. We have a CSV file that describes all the covariates and also the paths to the actual data file, and so it's a COINSTAC format, and the path to the actual data can be in multiple formats. Let's say that you have a bits directory, that can be a path to the bits directory. So we can work with different formats, but it is packaged in a COINSTAC format. So the vault data has to be put into that COINSTAC format. Yeah.
Two follow-ups.
Please do. Yeah.
I'll come close. So there's like the first one that comes to mind. Okay. Hello, can you hear me?
Yes. Thank you.
Another questions was with regards to data sets where a participant, for instance, withdraw from the study. That typically happens for clinical data sets. I was thinking whether like COINSTAC had a way to handle this use case more than, I don't know, having to like resubmit a new vault or like something like this.
I see. So you're asking about a participant in the middle of collecting data withdraws from.
Sometimes it's even after. Like I can one data set I can think of is UK Biobank. Like very often they published erratum where they say these participants withdrew from the study. So please make sure that you're no longer running your processing through them. And I was thinking these frameworks where you need to basically add some more metadata to describe what can be computed by the federated learning platform. Is there any way to handle this use case like in a fast way rather than having to redefine the metadata completely?
Right. Yeah, we haven't come across a use case like that yet, I would say. Typically, the data is pretty frozen. So far, the vaults that we have worked with, and it was all in one shot in terms of making it as a COINSTAC vault. But yeah, it is something we have to think about. Yeah, the process for that.
If you want to use this in a hospital setting,
Mm-hmm.
this is very likely a use case that's quite important. I'd say if you're working on data sets that are like openly available and like frozen in time with like
Right.
releases that are like that consent has been given and like the data collection is over, the formalism is over, and now the data set is basically available to everyone to use and run analysis on, then it's absolutely appropriate. But I would for instance, in my use case, I'm quite interested in federated learning usage for hospital settings where it would be very difficult to get consent and agreement on all the hospitals to aggregate all their data into one data set and, provide it and put the necessary provenance and governance in place for everyone to use the data properly. So here, federated learning really has a use case that's like amazing, where you basically just every single provider of the data just takes care of his consent, and then you just share aggregate statistics between them. But one of the challenges for this specific setting is that at any time, one of the hospital can say, we have someone who withdrew from the study and we need to make the appropriate changes so that the intermediate statistics no longer aggregate this information. So it was just, if it's not taken care of, that's fine. It was just like a general.
Yeah, absolutely. It's definitely something to be considered, to be able to make updates to the vault data, right, in a sort of dynamic way. Soon as we have some information, we update the vault right away so that the group analysis does not consider those participants.
So
yeah.
in
So
that case, the update would happen on the vault level, I guess.
yes.
What about the past results that were computed and needs to be redacted? Would there be a way to somehow propagate that to the rest of COINSTAC, or are essentially the services that handle the vaults, the computation, the results, which are nicely showcased in the UI, like on the left-hand side? Is there like some way to basically orchestrate them so that, like, if there's an update to the vault, like everything gets somehow rescheduled for a new batch? Or is it still a manual process that would be?
Right. At this point, the way it works is that setting up a new consortia and a new project and rerunning the pipeline with the vault data will basically give you the appropriate results. But in terms of dynamically updating the older results with the change in vault data, that process is not set up yet. But it's definitely something we want to include. Yeah.
And one more question, if I may.
Yeah, absolutely. Keep going.
Another important aspect for the very same use case that I described is at the very end, you want to get some form of provenance information of your final model. So at least you want to say that it was trained on data sets from these different sites,
Yes.
without identifying information, but at least you want to say that the model has been trained on
Yes.
at least the sites, I would say, and maybe some IDs which are like machine IDs, but at least the idea would be to have this kind of information. First of all, is there support for something like this? And if not, would that be difficult to implement, I don't know, through a plugin? Or I don't know if, for instance, is the architecture designed in a way that we could, for instance, provide plugins to get additional data out, or that would be that's one the small question. I would say the bigger question is how extensible is the overall framework? Where can it be extended to accommodate for use cases that are beyond what you just showed?
Okay. I think in terms of the first question, sharing information about the vault without revealing the underlying, protecting privacy of the data set, that would be possible. And that is something we are working on in terms of what can be shared without somebody trying to decode the original information, right? At least some level of summary statistics. So that can be done. And especially for public data sets like the vaults, we have already shared with you some information on their age range and information like that. But for private data sets that have very sensitive information, I think some level of summary stats, I believe, can be shared, still protecting the privacy. And in terms of extending the COINSTAC framework, I did not get the question. To what would you want to extend it to, like other use cases?
So what I just described seems to be not implemented yet. So it would be either we make a feature request to your team and they would design it. That would be great. But I saw that you have 5 or 6 engineers, which is already larger than any research project. So it's really nice.
Right.
But I was thinking, if you want to outsource, let's say, the extension of the framework to the rest of the community, you could design in some places plugins that could be provided by the community. And I was just wondering whether that was an area or that was considered, or whether COINSTAC was more considered as a distribution of services that are rather closed for modification, but at least you have the overall control of what happens and you don't outsource anything to the user where anything can happen.
Right. Yeah. We have opened it up to community development in the past, but it's mostly in-house software engineers who have worked on our software, right? So I would say it is heading in that direction because it is open source, and we would like it to be in a place where there can be plugins added by the community. We are heading in that direction, but right now I would say it's mostly in-house software engineers doing the work. So it will be a feature request at this point. Yeah, but definitely, I would say I'm in support of that for sure.
Right, thank you very much for your time.
Thank you.
Okay, so we receive a comment from online from Bradley Baker. He says, "Oh, sorry. Yeah, he said, I'll just read it out. Okay,
Yeah.
for the audience on site. Okay, he says that it is a good idea for the future to try to allow for federated learning with different local pipelines, but shared statistics. Yeah. Okay.
Right. Yeah.
So just a couple of questions. So, yeah, I mean, it's been brought up the idea of how you use things like the UK Biobank and some of the complications that you have, and these kind of regulations seem to differ based on whether it's in the UK, whether it's in the EU, whether it's in the US. So for a Human Connectome project, if somebody pulls out of that, you don't need to remove any of the data. So in that sense, it's really nice to have this federated analysis. How are you thinking of kind of integrating those large data sets into COINSTAC? Because if you have that kind of comparison data set that you can easily compare VBM results or your cortical thickness or whatever it is, it provides a very nice powerful way of taking smaller data sets and then having a nice way to quickly compare against that.
Absolutely. We definitely are heading in that direction in terms of making available some public data sets that people can compare and contrast their local data to. And in fact, one of the ideas in the works is that we have this huge curated public data set available as a vault, and users have this local data set, and they're able to quickly compare their local data with the vault data for some summary stats, just to see if their data, like for example, the unsupervised dimensionality reduction technique, right? You can throw in some N measurements, like say quality control metrics on their raw data or pre-processed data, right? And you just see if their local data is close in to vicinity to the vault data, in order to consider it for a group analysis project, or if it is such an outlier compared to these vault data sets, right? So that is definitely something very exciting, and we're definitely in the works for that. Yeah.
And about other modalities as well. What kind of scope do you have in mind for the types of different analyses that people will be running? Is this including diffusion, ASL, and various? Is it everything that you can run in SPM or FSL or AFNI or whatever?
Right. All the major toolboxes that people use to process neuroimaging data, we are slowly starting to integrate them. And DTI, ASL definitely are there, and we definitely use FSL and AFNI, these toolboxes in the back end. So those are in the works, and even branching outside of brain data, it could be, I would say, we do have a project that we are in the talks with that could involve data like heart rate measurements or other data that can be available outside of just the brain scans, right? And let's say that you want to do a baseline comparison of that with a group of individuals, and so there are expansion plans for that. So yeah, it's definitely in that direction. Thank you. Yeah.
Great. Well, in that case, yeah, I'd like to say a huge thank you. I think it's really exciting, isn't it? The kind of possibilities that you get with these with COINSTAC, and you can definitely see it being used in many cases. I've got a grant idea with it already, so I think I'll
definitely talk. Yes, absolutely. We would love to invite everybody who's interested to email us and chat with us. That'll be great.
That's perfect. Thank you very much, Sandeep.
Thank you.
And thanks to the audience.
Thank you.
Okay, so I think we're going to call it off there. And so, yeah, Brad said he's going to be around at the poster session. So if anybody wants to talk in person, get in touch with him there. Thank you. Yeah, Brad, have you got the poster number there? He's in the very fortunate position of being on lots of different posters. I need to figure out which one. 0419? 0419 he's on. Talking using reference. Fair. Yeah, it sounds like you've got good ideas in mind for this already.
So, so I work with the area engineering team in France,
Mm.
and they also have a project called federated, which is a federated learning platform, but very specifically tailored for medical image analysis.
Yeah.
Where the idea is that you would bring this platform to hospital settings where these sort of regulatory, we even have this on like the regulatory constraint
Yeah.
you get from analyzing medical imaging data directly from the source of that acquisition rather than from a curated data set that has been like a scheme. But the major difference I can see between the two things is that to me, Vaults, if I've understood correctly, is that you basically start from like an already curated and like saved data set that basically your DP, your data
held
protection
locally.
officer would have validated and say, okay, it's safe for sharing.
Yeah.
And then Vaults will compute the necessary metadata so that then each of the participating nodes of the fidelity network would run the computations. Was for us, it's the actual opposite, something that the data being required, we got the consent of the patients who participate in the research.
Yeah.
As far as we are concerned, that's the only thing we missed, because the hospital is responsible for its own governance data.
Yeah.
But then the federated learning network framework basically ensures that then whatever transits within the computation graph network is anonymized and purely statistics.
Yeah.
You get back
The final results. Yeah.
Which in that case, especially in France, where we're very regulated.
Yeah.
Almost some would say over.
Well, the UK definitely has the same problem. Yeah.
It's the initial normalization processing of the UK biobank was the period where the first access to data.
Yeah.
It's quite something.
It says.
The example of the UK biobank.
Yeah.
It's just a scar.
Yeah.
But yeah, we just realized that the nice thing with medical imaging analysis is that it's so regulated, so constrained that it looks like if you start from that angle, every other use cases sounds similar.
Yeah.
In comparison. And yes, in the end, the idea would be that all you need is like the consent on the data, like the governance on the data acquisition level for each hospital sites.
Yeah.
And then it's the federated learning network that ensures that whatever transits won't leak any of the private the site-specific information
Yeah.
network.
Yeah.
And with the hope in our case, we already know that that's already fulfilled, is that compared to aggregate a huge data set coming from all these sites,
Yeah.
where you need to recruit every single DPO and hospitals can also come from, like, in the UK, I think we have like trusts, so I guess the trusts
Yeah.
have to like
But the research institute and the NHS trust would have to have this, and they've got tight data management plans for exactly what happens at every step with the data. Yeah.
which would be like an overhead that's so huge that
Yeah.
we've had studies, for instance, in France, where people, like some private investigators have complained that they put together some funding for a project, and they secure the funding, secure the person who's supposed to work in.
Yeah.
But the access and regulatory aspect to get the data from the hospital setting was so long. And
Yeah.
the funding almost ran out.
Yeah. It's common in the UK, definitely. Yeah.
It's fine. It's madness.
Yeah. But I mean, in some sense, what it needs is somebody to go through the process in each country, and to, to get the, one of the trusts or the local centres to grapple with the idea of this and demonstrate, or to go through, figure out, how they perceived it, whether they brought up any other kind of illegal issues, and at that point, once somebody's scarred and burnt by the process and can teach everyone else, then then it becomes very commonly used.
In real works on it, like they've been burned so many times.
Right.
Like that they've, at least for the French system, they've ironed, like,
Yeah.
they ironed most of the
Yeah.
But of course, from one country to the other, I suppose in Germany it would be also different.
Yeah.
In the UK, I had a taste of it with UK Biobank. I would argue that actually UK Biobank is not that bad.
It's a contractual element at the start. Once you get past the contractual parts, and as you say, there are some kind of quirks with it, but after that point, it's not terrible. Yeah.
Kings have had way more difficult data sets to handle.
Yeah.
So in comparison, I found that UK Biobank showed the initial project proposal, agreeing on which metadata of the data catalog access, making sure that your project is novel enough that they don't tell you need to pay with someone who's there and stuff.
Yeah.
Is like the contractual aspect, the contractual negotiation is a bit long. But afterwards, what they ask you is fair.
Yeah.
Like, we publish you an addendum every once in a while. It's a responsibility to make sure that you impute the data that are supposed to be redacted from your copy of the data set.
Yeah.
Instead of saying you need to go through like a centralized platform, which I've used that me. I wouldn't say I'm a very big fan of their platform.
Yeah.
Mostly because also they've decided multiple times to change the coding and change the path of the files without an item.
Yeah.
Like, for me, it's like an email.
Yeah.
Comparing with the craft. So we are providing this.
Yeah.
Is a full-time job as well.
Yeah. I do think, if they can, because there was this big Nature paper last year, wasn't there, on these brain charts, and and it's the kind of thing that should be, great, and should move things along at a much faster rate, because you've got this normative data set. But it's not being used as much, yet. And if you could integrate it into these systems as well, then you could get a very nice kind of first pass before you start running your other analyses, and then just look at divergence. When if you take patients with particular kind of conditions, you could try and find out when do you see acceleration away from normative levels and all of these things. That would be,
Well, it's just
Good way to do it.
there's also a level of inertia that's like,
Oh, that's true. Yeah.
that's just very difficult to do. I mean, when you think that some of the studies have been going for like 10 years almost, I guess, I don't know if the wavelength was supposed to last like very long. I don't remember what the length of the initial proposal was to explore.
It's been extended already. Yeah.
I'm pretty sure it was, is it 10 years?
I thought it was 10 years.
10 years.
Yeah.
And I got access to it in 2015, 16, it was the very first batch of the, after it was like privately given to design the initial quality workflows with the partners. And I was like, wow, 2026 is not that far away. So it's been extended already.
Yeah.
Yeah, it's well, we're going to see some nice patterns of like scanning drifts and like.
There's all that as well. Yeah. But I think yeah. So they've actually they're moving premises now. So they're moving into Manchester, moving all their samples and everything else. So they're in for the long haul, and they're integrating with the universities and things. So
They still plan to do data acquisition on their own sites.
For scanning.
Yeah.
Yeah. So they're calling they're calling people back for the longitudinal scanning now, and so as far as I know, they've got funding to do that. They're planning to do it. How many times they'll do it, that I don't know, and how many people you end up with. But it's still in the magnitude of thousands, isn't it? So for any normal analysis, it's ridiculous.
I remember back then I was working on the cardiac side.
Yeah.
And like one of the first things we did was like just explore the data set and realize that actually some of them were wrongly coded. So you would have like views, like data sets corresponding to specific views of the cardiac volume that were wrongly labeled. It was swapped, you could say, a 2-chain view with a 4-chain view from it. So anatomically, like if you were to train a model on this, the model would be like 1 million, right? Looking at completely different things.
Yeah.
So, and we came back to that and say, well, we can build a simple quality pipeline that just tells you whether something is like a view is wrongly labeled. And we're like, oh yeah, we would definitely accept this. We already have like 2 or 3 contractors that were doing the actual QA, semi-automatically. And the question was, oh yeah, but we know how to actually interface with all the partners that the one who selected.
Right.
So we had to let them come in period, and I realized how small the team was.
Yeah.
Genuinely small. And this huge endeavor, it's like massively small team.
Yeah.
Like we ended up agreeing on how to what would be the process to give back the data that were corrected, metadata that were corrected,
Yeah.
how to feed back the pipeline to them. But it was also very, like, it's always sometimes nice to see what's behind the curtain. Like, you see that like this UK pipeline, which is like on the surface, like, an amazing. Like, you realize that it hangs on a thread of like a staff team that's very small, and barely funded what it should be. So but we have like a huge turnover. It's like the protocols are really tight. Try to cram as much as they can in the brain, cardiac, and whole body session. And they were like telling us like, we have a lot of radiologists that just like burn out, or like
Wow.
they just their turnover was unexpectedly high. And as a result, that would explain why we would see these inconsistencies sometimes. Because as a result, the new people coming in, they're trained, they're being trained, and they can do these mistakes. Or sometimes they told us like we have people who've been there for a while and actually decided that fuck the protocol, I'll adjust it to my
Yeah, idiosyncrasies start creeping in, and then it's problems.
Some of them are like higher like tiny bit higher resolution, and the guy was like, "Oh yeah, that half is a bit smaller," so I decided to adjust the field of view and like make it tiny bit higher resolution, so that it's gonna helpful make the data is gonna be higher quality. Yeah, but
yeah.
It's from the baseline.
Yeah.
So yeah, all these work stories were like very enlightening. Just realized that just the data acquisition and collection and stuff. I got huge respect.
Oh yeah.
And the results.
I think this broadcast. So thank you to everyone who stayed online. Yeah, I think so. Sandeep has headed off. Brad, as he says, will be at the poster session. So if you are local, then you can come in. But if not, then hopefully you have the QR codes from the talk, so you can contact Sandeep and Brad and others. So thank you very much for staying on, and hope to see you at the next sessions.